This is a quick start tutorial on ibaRotate. We will take a look at the general handling of the software and basic functions. After that, you will be able to explore the powerful possibilities of ibaRotate on your own. Here you see the main window with the signal list on the left and the toolbar above the plot workspace. When working with ibaRotate for the first time, you need to set up your preferences. To modify these settings, open Edit, Preferences. Here you can choose your frequency unit, the default waterfall plot type you want to see, and the directory where the results of the calculations will be stored. Apply these settings by clicking OK. This will take you back to the main window. To add a new signal, right-click in the signal list and choose Add Files. You can find a demo file in the installation folder for ibaRotate. Select and open this file. The file is now added to our signal list. Let's have a look at the two channels. By double-clicking the signal is plotted in the plot workspace. The resulting plot is separated into two windows. In the lower window, you can see the entire time waveform, and in the upper window, you can see a zoomed-in area of our cursor position. As you can see, the plotted channel is a tachometer signal varying between 0 and 4 volts. To zoom into a time waveform plot, right-click anywhere in the plot, click Zoom and draw a rectangle around the area you want to zoom in. For further information on the signal, such as sample rate and number of points, you can right-click on the signal in the signal list and click Properties. Here you can find all metadata related to the signal. We now have a look at channel 2. This is the acceleration signal we want to analyze. It was recorded using iba hardware. To generate a waterfall FFT plot from this signal, we select the signal in the signal list and select Waterfall Analysis in the toolbar. Here the standard settings for FFT analysis can be made. For our demo data, we'll select a block size of 4096 and 200 as number of spectra. After clicking OK, the waterfall plot is generated. To change the orientation of the waterfall, right-click on the plot, select Orientation, and drag the waterfall in the direction you would like to see. Zooming in on the X-Z axis works in the same way as in the time waveform plots. In the next step, we want to use the tachometer signal to improve our analysis. Therefore, we need to calculate the speed signal from the tachometer signal. To do so, we select the tachometer signal in the signal list and select Tachometer Processing from the toolbar. Here we have to select Pulse Waveform as a tachometer type and a trigger level between 0 and 4 volts. In case you have a different type of tachometer input or need to smooth out some measuring inaccuracies, additional settings can be configured here. After clicking OK, we see a plot with two curves inside. The blue one is a calculated raw speed. The green one is a smoothed speed signal we can use for our analysis. To use this signal for our analysis, simply drag and drop the signal into our waterfall. Right-click on the plot and open Properties to select new units for axes and cursors. To demonstrate, I will switch the cursor unit from hertz to orders. We have now added a speed-dependent cursor, showing, for example, that these peaks are related to the third order. This was a quick overview on getting started with ibaRotate. For further information, feel free to contact your local iba support. For detailed descriptions of all functionalities, please consult the manual or ask us for individualized training on ibaRotate.